Sorry, I'm not sure if you already started, but we can't hear you.
Hi, hello. Can you guys hear me?
Yes, we can hear you now.
Okay, perfect. Thank you guys so much. Otherwise, I'm going to give a kind of like lecture for 2 hours and then realize no one can hear me. Okay, great, great. So let's start over. Sorry. Okay. So let's try to recap what we have been learning so far, right? So in the last couple of lectures, we have been talking about essentially two things. So we talk about relational model, that is how we organize the data and the knowledge we have as a collection of relations. So I will not go into the detail about the details, like about the definition again, but essentially when you have a database instance in a relational model, you are essentially having a collection of relation instances. For every single relation instance, you can think about it intuitively as a table, right? But with some caveats that we talk about. And to define that, you define the schema of the relation, and then you define the instance of the relation. The schema is pretty much the structure of the table, like the header, and the relation instance is really the content. You can introduce a whole bunch of constraints over the relation to define what is a valid database instance. We talk about two different ways to introduce constraints. You can introduce constraints by specifying the domain of each attribute of each relation. Some of them are strings, some are floating point, so on and so forth. You can also introduce constraint by specifying some subset of attributes of a relation to be a primary key, right? Which means that there cannot be duplicates on that subset of attributes in that relation instance. We talk about how to get insight out of this data, and that is by querying it. And we talk about different query languages, right? So at a high level, query language is a set of functions that you can specify. And that's a set of functions that actually maps a database instance to a new relation instance. And the query is simply one of that function. And the query language is specified by the collection of functions that it can express. And in the last lecture, we talked about essentially two different ways of querying my data. And the first way is by relational algebra, and the second way is by relational calculus. And if you put them side by side, one of them is declarative, one of them is not. Relational calculus is a declarative query language, which means that you only specify the property of the that you have on the result without telling the database how to get it for you. And the job of database system is automatically find a way to get the result. We talk about the relationship, right? So we first established that relational calculus is more powerful than relational algebra, which means that there are some queries that you are able to express in relational calculus, but not in relational algebra. And that can also cause problems because those queries that you are able to express in relational calculus, but not in relational algebra, are those queries that are not safe. And we gave a precise definition about the safety of queries. which is that if you give me a database instance of finite size, which is always like that because we live in a real world that database is finite, whether you are going to get an answer with infinite amount of tuples in it. If that is true, we call query to be unsafe, right? So relational calculus can potentially give you unsafe queries. And then we talk about one way to constrain its semantic such that you can only specify safe queries. And that is a subset of relational calculus queries that you can express. And we call that domain independent relational calculus. And we show that intuitively, without the formal proof, that it has the one-to-one correspondence between relational algebra and the domain independent relational calculus. And then we talk about two subsets of this. We talk about relational algebra with only selection, projection, join, and renaming. And then we talk about conjunctive query, right? So there's a one-to-one correspondence between these two query languages, and they are all subset of relational algebra or domain-independent relational calculus. On the theory side, we walk through these 5 different query languages. And today we are going to essentially try to see how to write queries in real world, in a practical database system. And that is by writing SQL queries. And as we will see, we will first introduce the set of SQL queries that you can write that has one-to-one correspondence with conjunctive query. Okay, and that is by using probably the most frequently used statement, like a select from where, right? So when you're writing SQL queries, this is probably the most popular thing that you are going to write. And then we are going to introduce a larger subset of SQL to give you the power of writing any relational algebra expressions. And because the one-to-one correspondence between relational algebra and domain-independent relational calculus, we now give you a subset of SQL queries that can specify any query in domain-independent relational calculus. And then we are going to go a little bit beyond about the theoretical structure we provide for you. And we are going to talk more and more about some functionalities provided by SQL and the practical database system that you cannot specify in relational algebra without extensions. So last lecture, we kind of scratched surface about some components of SQL, right? So there are 3 different components. The first component when you write a SQL query is to define your data, define your schema, right? So, and that is the DDL part. It provides statements to define the schema. So theoretically, right, this is how you specify a relation schema, right? So you have relation name, which is R, and you have a whole bunch of attributes, f1 to fn. And for each attribute, you have a domain, right? All the value I could take for that attribute. So in SQL, you need to provide the name of relation, the set of columns or attributes, and their types, right? Which is pretty natural. And as almost all the existing programming languages, right? So the system provides for you a whole bunch of predefined data types. Okay. And then if you want to define a relation inside a database, you can do something like this, right? You can just create a table, right? Followed by the name of the relation. And then you can list every single column or attribute you want to have, followed by their type. And then at the end, you specify the primary key. Okay. So if you do this, the system is essentially going to define a relation with a schema look like this. And then we talk about another component of the SQL language, which is what you can do after you define the schema. That is, you can actually manipulate the data inside that relation. You can insert new tuples into the relation, and you can update tuples in the relation. And there are 2 ways to really populate the relation, putting tuples in it. The first way is do that tuple by tuple, right? So in SQL queries, like in the SQL language, we provide the insert into statement for you to actually insert tuples into that relation, as the name implies, right? For example, if you keep doing this, like, so if you run these 3 statements, right, you are going to populate the table or relation and get something that look like the relation on the left-hand side. So in practice, that could be slow, right? Why? Because every single time you give me a SQL query, essentially database need to parse it, need to optimize it, need to plan for its execution. So that could be slow. On the other hand, right, so whenever you actually update the relation, the database need to recheck all the constraints you have on the database instance. For example, you need to check whether the key constraint is getting violated or not, right? So essentially, whenever you are running one of this insert into statement, the database potentially need to go through all the tuples in the data, like in the database, and try to check whether there exists one tuple that violates the key constraint, right? So of course, if you have some other data structure of the relation, it can do that much faster. But when you are inserting millions or billions of examples, that could be very slow. And that is why most of the modern database systems give you some functionality to load a whole bunch of tuples all at once, right? For example, here in PostgreSQL, you can just put your data into CSV or TSV, right? And you can just load them at the same time. It's often faster when you have a large table to fill in, right? Because you are only essentially checking the key constraint once, and then you do not need to parse millions or billions of those insert into statement. So if you think about what's really happening here, right? So you have your database system that you interact with as a user, and this is you as a user, right? And then you have your computer, right? You have your memory, you have your hard drive, right? Whenever you are creating a relation inside database by just issuing the create table statement, or whenever, so what's going to happen is database is going to create a relation or table that is stored on the hard drive, okay? Even like such that even if you pull the plug of the computer, when you restart it, the data will still be there. And whenever you insert data into it, it will also store the information on the hard drive. And the second way of interacting with the database system is, as we will see, whenever you issue some query to the database system, it will try to bring this information from the hard drive to your memory and return the result back to you. This is the interaction model that we have with the database system. Okay. So the goal of the database system is really try to understand that, really try to make sure that you as a user do not need to worry about how the database is bringing the data from the hard drive to you. All you need to do is to specify what you want, essentially doing the thing on the right-hand side, and then let the database worry about everything on the left-hand side. In an ideal world, at least that is what database try to do. Okay, in some application, it failed to do that, but ideally that is the design goal of the system. Okay, so in this lecture, we are going to talk about how to query data by writing SQL queries. Okay, and we are going to look at a very small demo about how database is working in practice, and then we are going to keep defining like larger and larger SQL subset, which provide more and more advanced functionality. Okay, so let's start from the basics. Okay, so the most popularly written SQL queries might often of this form, right? So it is actually one way for you to implement a very simple subset of relational algebra or relational calculus queries, and that is those with selection, projection, join, and renaming. Okay, so let's look at this relational algebra expression, right? So if you look at what is it trying to do, right? So it's first run a selection over the professor table with the predicate that level equals to FP, right? And then it does one projection and only keep the personnel number column and also the name column, right? So if you want to implement expression like this in a practical database system, you can just write a query, look like the one on the right-hand side. You select personnel number name from professor, the name of relation, where level equals to LP, which is the condition of your selection. Okay, so as simple as this. And you can see the one-to-one correspondence of the structure. So like you put the relation, right, that you run the selection on after from, okay? And then you put a condition after where, and then you put a projection list after select. So the beauty of this is the query on the right-hand side. You can almost read it in almost like a natural language, right? So that's the beauty, right? But underneath the cover, every single time you are actually writing a SQL query that looks like this, you are actually specify something that's very mathematically precise. It is a relational algebra query like this, and you also express kind of a like relational calculus query, right? So, and sometimes you're going to write down the whole list of projected attributes if you do not want to do projection. Okay? You want to keep all the columns, right? So, for example, if you want to do a relational algebra expression look like this, right? So my professor table only have 4 columns, right? So I do not want to do projection. I just want to keep all the columns, right? So you can actually replace the projection list as a star. Okay, you can select star from professor where level equals LP, right? So that's going to implement the same thing as a relational algebra query look like this. And you can do join with the same syntax. Okay, so when you want to join 2 tables together, what you are going to do is to put the relations you want to join after from. As you can see here, we have essentially 2 relations. And then you put the join condition here after where, and then you put whatever selection condition you want to have for every single table, also after where. Okay? And you can connect them with some logic operators, maybe and, maybe or, whatever. Okay, and you can do projection over the join result. If you think about this, right, essentially you are implementing the relational algebra expression that looks like this. In this example, you want to do a join between professor and lecturer. Essentially, you want to find all the lectures that a professor teaches. So you join these 2 relations with the condition that the personnel number column of professor need to be equal to the prof number column of lecture. Okay, and then I want to further sub-select the database. I want to only worry about the lectures with the title equals to database. And once you do the join, right, and the selection, you do one projection, only keep the name of the professor. Right. So if you want to do this relational algebra expression, you can simply write a SQL query look like this. And you can see the one-to-one correspondence in the structure. Okay, so everything after from in your SQL query corresponding to this cross product. Okay, and then you have your all the condition, either the join condition, right, and all the selection condition, whatever, right? So after where, as always, and then after select in your SQL query, you put all the columns that you want to do the projection on. Okay, so it's as simple as that. From actually defines a list of relations that you want to do cross product or you want to do join, right? Where defines the selection condition, select defines the projection. Okay, so essentially, if you give me a SQL query look like this, you are actually specifying a relational algebra that look like this. Okay, so here you have join like k different relations, R1 to Rk, right? You put all of them after from, And then you have your join condition, your selection condition, P1 to PM, and you put that after where, okay? And you have your projection to column A1 to AN, you put that after select. If you want to give them a different name, you can do renaming afterwards, and then you can just say select A1 as some other name, okay? So it's as simple as this. So I know this is pretty abstract. So one thing that we are going to do in the next 2 lectures is really to have 2 hands-on sessions to make sure we all write SQL queries together. So once you have a real database in front of you, once you start to write this in a real database system, it will become very clear what we are trying to do. Okay? But theoretically speaking, it's very important to see the one-to-one correspondence of the structure between a SQL query that you are going to write in practice and a query in theory that we have been talking about, either relational algebra or relational calculus queries. Okay, so, and you can do a whole bunch of things. Essentially, you can implement all the operators that we have been talking about in relational algebra. Okay, so we talk about the union between 2 relations. In SQL, you can do something like this, right? So if you have 2 SQL queries, here I want to select name from assistant, I want to select name from professor, right? So each one of them is like a SQL query, right? You can union the result by just write the union here, right? So in this case, it will actually really do the union like between these 2 results, right? From like one for each query, right? And you can do intersection, right? So depending on what database system you are using, right? Sometimes you can write intersect, sometimes you can write except, right? So that depends on the database system itself. You can do different. Oh, sorry, yeah. So like intersection is always intersect, right? And you can do the difference, right? In PostgreSQL, you write except here, right? If you do this, it will get the result of the first query and then minus the result of the second query. Okay. Yeah. And one thing that we need to keep in mind is that in relational model, we always introduce, we only introduce a set semantic. The relation is a set, the result is a set. So there's no duplicates. When you are talking about the database in practice, it actually have a back semantic. Okay, so let's look at one example. So if you give me an input that look like this, I have 3 professors. Okay, so if you give me a SQL query look like this, I want to select level from professor. Okay, so essentially, I want to essentially go through every single tuple in the professor table. I want to project them onto the level attributes. I want to throw away like personnel number, the name, the room. I want only keep one attribute. So if you do this, right? So the result that you're going to get is going to contain essentially 3 tuples. Okay. So the first tuple we have a value AP right here. We have the result here. The second tuple FP, LP, LP, LP. Okay, you have 3 tuples in the input. You have 3 tuples in the output. As you can see, there are duplicates here, right? So the second row in the output equals to the third row of the output. So this is because the database actually have a back semantic. It will not do automatic duplication elimination for you. If you want to do it, you need to do that all by yourself. Okay, so this is just like another example that the database has a back semantic instead of a set semantic that we have been doing in theory. If you want to do duplicate elimination, right? So the database actually gave you one way to do it is by writing distinct here. Okay, if you give me a SQL query look like this, you select distinct level from professor, right? So what database is going to do is to do duplication elimination for you, and in this case, it's going to remove the duplicates on FP, and then you are going to have a relation as the output with only 2 rows. Okay, one is AP, another is FP. Okay, you can think about this as you run the duplication elimination, from the So how many? Okay, yeah, okay. So yeah, somehow my mouse cursor doesn't work anymore for whatever reason. Yeah, so if you look at this, yeah, so like essentially like a second relation, right? On the right hand side, essentially you are doing like duplication elimination. Okay, so I saw someone raise the hand. Just go ahead.
Yeah, there's a question regarding the name. So in your snippets, the whenever it says name, it's blue, and the chat is asking themselves why that's the case. So I'm not, maybe it's on the slides before, but yeah, you see name here is in the color blue, and they don't know why.
Oh,
So, yeah.
okay. Oh yeah, sorry about. Okay, so like this is just okay. So the color is done automatically by the editor. So I think it's just somehow treat name as a keyword. But it doesn't need to be like that. Yeah. So the color, so the blue color of name doesn't have much meaning here. Essentially, it's simply that the editor I'm using think is a keyword. I think it is a keyword in SQL. Yeah.
Okay, thanks.
Yeah. But if you are putting a generic string there, it's going to be of white color. Yeah. So like logically, name should be white. Okay. So like name shouldn't be blue, like in that position. Yeah. Okay. Cool. Okay. So and then you can do duplicate elimination over multiple columns, right? So for example, if you say select distinct name level from professor, right? So what it's going to do is going to do duplicate elimination over the combination of that two columns. Okay, it's going to only keep the unique like value of the pair. Okay, so here's just one example, right? So if you run a SQL query look like this, right, the output is going to have essentially 3 tuples, right? So yeah, so I saw two people raise hand. Yeah, go ahead.
Another question from the chat. What is the semantics of except when running against relation with duplicate entries?
That's a very good question. Actually, I don't know. That is something I need to look up. Yeah, that's a very good question. Yeah. So I will send out something after the lecture that you can read and see the precise semantic. Yeah. So if I must guess, it should implement the back semantic duplication in the sense that if I have, yeah. Yeah, so somehow it doesn't, the computer is weird today. Yeah, sorry, my computer is a little bit weird today. So you guys can hear me, right? Can you? Okay, sorry. Okay, I don't know what happened. Okay, great. Yeah, so I mean that is something we can try. Okay, so short answer is actually I don't know, but that is something we can try. Okay, let's create a relation R with one attribute here. Yeah. Okay, so essentially what we want to do is we want to select. Yeah, let's do one value here. Let's give you 2. this. Essentially, question is, what if we run the fundamental question? Right? Okay, so it seems from this, so essentially if you look at len4, right? So this is going to be a relation with 2 tuples. So this one is with 1 tuple. So essentially, if you look at this, so like this relation has 2 tuples, 1, 1. This relation has 1 tuple, 1, right? So it seems it's when you do accept, it's going to remove essentially all the matches. So that is what seems to happen here. I will send out so I will send out the link to the PostgreSQL reference. But I think this is what actually happened. Yeah. Okay. Yeah, go ahead. I think there are more questions.
Yeah, so to get back to the previous question about the name, you said that it was a keyword, but it's not treated as a keyword in this context. So does that mean it is possible to if you do something with the namings and stuff, that you have a keyword, use it as a name completely fine, and then in some context it's suddenly treated as a keyword because it's context sensitive and you get unexpected side effects?
Yeah, okay. So in principle, we do not recommend you to use any keyword and use that as the name of the column, right? But here, from the context, I mean, it's clear this is the name of a column, right? Like an attribute instead of like a keyword, right? So I think the SQL parser is going to be fine with this. But simpler the editor, right? So the one deal with syntax highlighting has some problem with that.
Okay, my question was mostly if we are using names like that, and we are going further and doing other stuff. Like in this context, it's fine. But could it be in another context that it's suddenly giving us errors that we're not expecting because we expect name to be treated like a name and not like a keyword?
I cannot think about an example right now. Okay, so I cannot find one example right now that concretely to say this one will cause this problem. But there could be, yeah. So does that answer your question, right? So that actually depends on how good your SQL parser is, right? So like I cannot think about any concrete problem that it might have. Actually, I never saw that when I using the database. But whenever I don't know how to run your query, it will let you know, right? So like it's going to give you a parsing error to say I don't understand the query you are writing. Right?
Okay.
Yeah.
Yeah. Thank you.
Okay. Okay. So is there any other questions? Okay. Cool. Great. Okay. So here we talk about the this kind of like duplication elimination here, right? So we talk about you can actually do duplication elimination over a combination of attributes, right? So if you think about what it's doing, right? So it's actually try to translate something from the back semantic to something with a side semantic with distinct, right? Okay. So again, SQL implement back but not side. Okay. So it's a very good question. What is going to happen if when you write except? So I will send out the link to the PostgreSQL reference. I actually don't know the answer on top of my mind. Okay. So one thing that's interesting is essentially every single relational algebra expression that we have been talking about on the theory side can be written in a subset of SQL. Okay. So this is actually easy to prove, right? Because we talk about essentially these operators in relational algebra, right? So And then essentially you can see they can be essentially written in SQL like this, right? You can do selection like this, you can do projection, you can do cross product, you can do renaming, right? So once you have this functionality, right, essentially every single relational algebra expression we have, you can write them down in a subset of SQL queries. And because of the one-to-one correspondence between relational algebra and the domain-independent relational calculus, it also means that you can write down every single query in SQL like you can actually write down every single query in domain-independent relational calculus using SQL. Okay, so that's this power of database. Okay, so this is the query languages that we have been talking about, right? So we go through a whole bunch of them on the theory side. And then we have kind of introduced essentially a subset of SQL queries, right? Like subset of SQL languages filled to express relational algebra and the relational calculus queries. In practice, database give you more, right? So database give you more functionalities that you cannot express in the relational algebra kind of language that we have been talking about so far. So let's talk about them. Okay. So one functionality that database provides for you is sorting, right? Because by default, database is a bag of query, so it's a bag of tuples, so it doesn't have order. Okay, so it doesn't have order among all the tuples it has. But if you want to enforce certain order in your output, you can actually order the result by certain attributes. Okay, so the way you do it is after your select from where query, you have one special thing called order by here. Okay, so like in this case, it's actually going to order the result by the attributes here, and you can kind of like specify the order, okay, whether it's a descending order or ascending, right? So if you do this, what it's going to do is going to do the projection. Let's update it. Make sure. Okay, so here what it's trying to do is going to get the result from select from where, okay? And then it's going to order by level and the name in descending order, right? So in this case, if you output something like this, okay, you can see all the tuples are ordered by essentially these two columns. Okay, so again, right, tables are not sorted by default, but if you want the order in your result, you can sort them. Okay.
A question?
Yeah, go ahead.
Back one slide.
Yeah.
How are they ordered? Like, I don't see the order in the name or the level.
Oh yeah, so here you first order by level, right? So as you can see, the level is LP, LP, AP, right? So from F to A.
Is it like alphabetically?
Oh yeah. So so like if it is string, right? So here level is string. So if you order by string, it's actually alphabetically, right? Like in descending order, right?
But like the name is so it first orders by level and
level,
then
and within level you order by name.
Okay.
That makes sense?
Yeah.
Perfect. Yeah. Okay, so and then you can do more, right? So one really powerful functionality that SQL can give you is something called aggregation. So essentially, what you can do is you can actually group all the tuples in the input relation by certain kind of attributes. Essentially, for every different kind of value of that on the attribute, you create one group and you put all the tuple within that group, like all together, and then you can do some aggregation over that group. For example, you can count how many tuples are there. You can calculate the sum or average, right? So here's one example. If you group by this attribute, like this relation by this attribute, right? And then you can put some aggregation function here. So what is trying to do is, okay, I want to group all the professors by their level. Essentially here, you are going to create two groups. You have one group AP with only the first tuple. You have another group FP with two tuples, okay? And within each group, I want to compute the count, which is like how many tuples are there within each group. So in this example, right? So the first group, like FP has two tuples. If you output the count, right? So so number is going to 2, right? So if you have another group equals AP, the count equals 1, okay? And you can do a whole bunch of aggregation functions like sum, average, count, so on and so forth, right? So I was trying to do is group the table by different values of attributes defined after group by, and for each group you apply the aggregation function. So here's another example, right? So when you do not specify group by, but only with the aggregation function, essentially you are putting all the tuples in the relation into a single group, right? So you can think about this as group by one empty set, then all the tuples belong to one group, right? So in this case, you will have a relation with a single row and with a single number that's 3, because you are actually putting all the 3 tuples into a single group, and you want to count how many like of them in that group. Okay. Okay. So and you can actually do selections over groups, right? So assuming like as you can see, like the complexity of queries, right? So it's getting higher and higher, right? So one thing that you can do for group by is I can also do sub-selection for each of my group to decide like which one should I output. Okay. So as you can hear, so as you can see here, right? So the first 4 lines is a standard group by query. Okay. So I join 2 relations, lecturer and professor. This is my join condition. I also do a sub-selection to only find the professor with level FP, right? And then I group them by their personnel number of the professor, right? And also the name, okay? And then I want to calculate the sum of credit point that the professor is teaching. And but I don't want to output all the groups, okay? So what I can do is to have like additional line here, the 5th line with having, and essentially I'm saying, okay, I'm going to apply this aggregation function over each group, and I only want the groups with every credit point larger or equal than 3. Okay, so if you do this, essentially after group by, I'm going to filter all the groups, and then I will throw out all the other groups that doesn't satisfy this condition. Okay. And you can do more in SQL, right? So one thing that you can do is you can have a whole bunch of subqueries, right? So you can actually put 2 like SQL query together, right? So there are multiple ways you can put them together. Okay. So one way is that you can have those uncorrelated subquery, which means that the query, like first query here, doesn't depends on the second query, right? So we are going to see one example like otherwise, like really soon. Okay. So here there's a kind of one thing you can do is called not in. So what it's trying to do is try to run this query first, and then for the first query, it's become essentially kind of a bag, right? So and for not in, essentially I'm like whenever this value is not in this bag, this where condition going to evaluate to true. Okay, so this is one way to do it. So and then you can actually have 2 SQL queries with correlation. Okay, so like this one gets a little bit complex, right? So it's getting a little bit complex because as you can see, I'm actually reusing the same symbol here. Okay, so essentially I'm trying to select all the professors where essentially there doesn't. So essentially here, so if you think about what system trying to do, is for every single tuple that I'm going to return for the first SQL query, I'm actually running the second SQL query, like logically, right? The database might not do that like in practice, right? But logically, for every single like assignment of the tuple here, I'm going to evaluate the subquery here once, and then I'm going to evaluate this not exist condition, which is going to return true if your like if this query, right, like returns empty. Okay, so like this is just like one SQL query for to write. Essentially, I want to find all the professors who does not teach, right? So essentially, I want to find all the professors where like essentially this evaluate to true, and when does this evaluate to true? It's only evaluate to true when running this SQL query for that professor returns empty. Okay, makes sense. So this is like we are kind of going through this really fast, right? So this just give you the structure about the things that we can do in SQL, right? So for the detailed like syntax, right? So you need to read the chapter 6 of the book, right? So that's probably the most efficient way for you to learn about it. Okay, so we talk about this kind of nested queries, right? So we can have two queries, have correlation, right? So and when you actually run that query inside the database, so what often happens, so is that database can often do automatic query rewriting to translate the query in a form that's easier to optimize. So for example, if you give me a less kind of nested query look like this, right? So in most of the database systems, it's actually try to rewrite it in a logically equivalent way, right? It's going to rewrite it into a kind of select from where query, and by kind of unrolling this nested query into a join. Okay, so let's take some break, and then we will be back in 15 minutes. So in the meantime, if you have any questions, just speak up. Okay? Yeah, go ahead, go ahead.
So, well, we saw the correspondence of the SQL language to relational algebra, right?
Yeah.
And we also said that relational algebra is an imperative language.
Yeah.
So wouldn't that mean that SQL itself is also kind of imperative?
Oh, no. So essentially, so essentially there's a one-to-one correspondence between SQL, right, and also relational algebra, right? But there's also one-to-one correspondence between relational algebra and domain-independent relational calculus, right? So here the one-to-one correspondence essentially for every single function you can specify in relational algebra, I'm able to specify in I'm going to specify that in SQL query, right? So it doesn't mean SQL is imperative, right? For example, when you actually write a join in SQL, you are not specifying the join order, right? So I'm joining relation R with S, right? So I'm going to write select star from R S where followed by the join condition, right? So that's actually corresponding to a whole bunch of like relational algebra queries, right? So I can join R with S, I can join S with R, right? So in SQL query, you are not specifying the join order, right? So essentially every single relational algebra expression you can express in SQL, right? So, but whenever you give me a SQL query, it can actually correspond to a whole bunch of relational algebra expressions with equivalent semantic. And when you run SQL query, you are not picking which relational algebra expression you want database to run for you. They are all the same. They are all always going to give the same result, right? So they are specifying the same function, but you are not specifying which one to choose. It is database job to pick the one for you, right?
Okay, so even in the case where we saw before that there are basically two queries that mean the same thing, but the I don't know what is it, the preprocessor kind of transforms it into the other form, like that doesn't make SQL imperative in any way.
You mean this example, right?
Yeah, exactly.
Yeah. So like if anything, this one makes SQL more declarative, right? So because as a user, you write something like this, and system automatically do the writing for you, right? So it's automatically say, okay, it's actually more efficient to run your query in this way, right? But as a user, you tell database what you want to do, but database try to automate it for you, right? So if anything, this makes the system more declarative, but like not less declarative. Right?
Okay, yeah, I'm convinced.
Cool.
Thank you.
Cool.
Hello.
Hello. Yeah. Go ahead.
I have a question.
Sure.
You said I'm not sure if I understood it correctly, but you said that somewhere next week or the week after we will have some practice for SQL.
Oh
Is that
yes,
correct?
next week we are going to have practice for SQL. Yeah.
Okay, makes because like it's kind of hard to practice and to really study and know that we know it without that.
Oh,
Okay, thank you.
exactly. Yeah. So it's very hard
Because
to learn a language without practicing it, right? So
yeah, I'm just reading the book and I'm just like, do I remember this? Do I really know it? And it's just.
oh yeah, we
Right.
understand
Oh, yeah.
that. Yeah.
And
So yeah, we totally understand that, right? So so next week we are going to have essentially 2 hands-on sessions that the TA will be here and we are going to write a SQL query together. Yeah.
okay, fair. And also about the book, you said we need to read the entire or you wrote that we need to read the entire chapter 6 for today and
for everything about SQL, right? So today, right? So since that we talk about on Wednesday, right? Today and also next week, right? So I think that's all chapter 6. Right?
Okay, so you will cover it because like there were some topics that neither were neither mentioned today nor last week, like for example transaction and everything. So I was. But
Yeah.
transaction,
So
for example, is going to come up.
transaction is going to come up. Yeah.
Okay.
Yeah.
Thank you.
Cool. Yeah. So we have one question. Can we define our own order by relation by defining a function that take 2 arguments and return an integer? Yes. Like in database you can do that, right? So like what you can do is you can actually like define a user-defined function in database, which we will not talk about, but you can actually like do that and then you order by the result of that user-defined function, which is also fun. Yeah. Yeah, so about the exercise, so we will start that like next week, so the third week. Yeah. So we do not have exercise kind of this week. Sorry for the confusion. Okay, great. So let's get started. So yeah, so like in the first half of the lecture, we have one question about accept, right? So what is semantic, right? So what happens when there's duplicates, right? So here it is, right? So essentially, right? So there are actually two operators. One is called accept, another is called accept all. Okay, so essentially, from the documentation, you can see whenever you are using accept, you are actually keeps the set of rows that are in the result of the left select, but not in the result of the right one. Okay, so which actually implies accept essentially going to translate like the left relation into a set and the right relation into a set and do accept. Okay, and then another thing is called accept all, right? So and then what I'm going to do is so we're going to keep all those kind of duplicates. Okay, so essentially whenever you are doing accept, so the system is going to actually translate it back to set and then do set accept. Okay, and then whenever you do accept all, it's going to do the back accept. Okay, so that's the difference. Okay, so essentially like this is like accept all, this accept, they are actually going to give you like different result. Okay, so you are going to see this very similarly when we are doing like union. There's union all. Okay, so yeah, that's the difference. Okay, so let's continue, right? So and you can do more, right? So there's something called all, any, or some, right? So and we will not talk about that in the lecture intentionally because I really want you to exercise and really access the process of learning by yourself. Because I mean, we are learning a language. There's no way we can cover all the details in the lecture. You need to practice by yourself, and whenever you don't know how to write some SQL query, you need to learn how to Google it. I mean, I hope I have a better way, but I don't think so. Okay, so if you want to learn about any functionality in SQL, right? So you just, for example, Google it. For example, if you don't know what any or some is, right? So just Google SQL any or some PostgreSQL or MySQL, whatever you want to do, right? So in this case, you do PostgreSQL, right? You do this, and then you are going to go to documentation here, like for the exam, right? So we are talking about this specific page, okay? And read it, and then you will learn like how to write that SQL query, okay? So please go back home and do this exercise. It's really important for you to learn this language, okay? So go to this page, learn about what is any, what is all, what is some, okay? We will have one once in the exam about this, I promise you, okay? So please go back home and do this exercise by yourself. And there's no way I can replace you in this process. Like you must be able to read the language reference and then learn about how to write that SQL query. Okay, that's very, very important. Okay. Okay, so now let's look at some more examples. Okay, so here, let's go back to our old university database with professor, student, lecture, so on and so forth, right? So and we talk about, okay, so what about this query? Give me all the students who take a database course. So we talk about two different ways of writing this down, right? So you can see this is a relational algebra expression. This is a relational calculus expression, right? And we want to do that in SQL, right? So this is just one way to to do it, right? So I can actually do a join between these three different relations: students, attends, lecture, right? And then I put my join condition here and subselect by title and do projection on the personnel number of students, and then I get it, right? So very easy to see. This actually three different ways of writing the query give you something equivalent, okay? In terms of the function is specified for you. Yeah, So, and then we can do something like this, right? So find me all the professors who do not teach this semester, right? So essentially, this is the two different ways that you can do, right? You can do relational algebra, you can do relational calculus, right? But if you are using SQL, right? So this is something that you can do. You can select all the professors first, and then you do accept, and then the second SQL query is you find all the professors who teaches. You join professor with lecture, right? And then you do and you project that to the personnel number of professor, and that's it, right? And this is another example, right? So it's like the query become a little bit long, right? But it's very easy to parse when you go back home and try to read this through. Okay. Okay. So this is kind of a very quick walkthrough about the functionalities that SQL provides for you. Okay. Again, like read chapter 6 and practice it by yourself. There's no way you can watch this lecture and get all the functionality of SQL out of it. Okay. So now let's look at database kind of in practice, right? So far we talked about database as a pretty abstract concept on a piece of paper, right? But in practice, you are going to use it like as a computer system, right? So we are going to look at essentially how to install database, how to create relations, delete relations, and alter relations, and how to issue some very, very simple queries. Okay, so the goal is give the feeling about, first of all, what the database really is, right? And second, essentially different ways that you can interact with the database system. Okay, and also we really hope to set up the platform that you can actually use later, right? To play with different database functionalities. It's very important to play with it. Okay, so we'll do PostgreSQL. So one thing we are going to do is we have one tutorial that we created on Katacoda. Okay, so and we are going to see what it is. Essentially, that's a virtual machine that you can actually run in your browser, make life a little bit easier. It requires you to log in, but if you are not comfortable doing that, you can just go to this link. There you can follow like all of this step by step. You get pretty much the same thing. Okay, we assume you have a Linux system which is reasonably kind of of a kind of reasonable version, right? You cannot have something that's too old, right? But something reasonable will do the trick. Okay. Okay. So let's quickly go through this, right? So like not go into the detail about how to write SQL queries, but more important is you as a user, how should you really interact with that system? Okay. So okay. So let's start, right? So at the very, very beginning, why do we have technical difficulty for all the things we have? Okay, here it is. Okay. So at the very beginning, right, what database really is, I mean, it's no different from any piece of software in your system, right? So you start from like install it, right? So and essentially, it's very similar, right? So I mean, you just I mean, if you want to install PostgreSQL, I mean, and this is just one way if you do not want to compile the kernel, right? So I mean, you first do apt-get, right? So you get all the dependencies, right? Update. We can just quickly go through this. Okay, so and then after you install it, right? So one difference between database and some other software is under the cover, right? So you are going to start a database kind of like engine as a service. Okay, so it's going to be one process that's running in the background. Okay, so I mean that is kind of one difference. So after you install database, you can actually start a database server. Okay, so like essentially this line is like in PostgreSQL, this is one way to start it. Okay, so once you start the database server, right, and you can see, okay, so I finished running this, but nothing happened. Okay, it's not going to bring you to the database. Okay, so one thing that's going to happen is it's going to start a process that actually serving you in the background. Okay, and to interact with the database, you kind of need to connect to that database server and then manipulate your data. Okay, and there are different ways for you to connect to database server. We are going to see it, right? But one thing that you can do, you can actually switch your user. You can run this command psql, right? And then you kind of start to connect to the database engine, right? So now you are talking to a database. Okay, make sense? And then you can do a whole bunch of stuff, right? So I mean, you can change your password or whatever, right? So like that you have in your database system, whatever, it doesn't really matter that much. And then now you are in a database, okay? So once you're in a database, you can actually play around. So for example, there are different, we talk about database instances, right? So you can actually do this and to get all the database instance already in the database system, right? So as you can see, even if you are doing nothing, right? So there's already 3 different instances, right? So they are the database instance that system are using, kind of store some whatever information that useful to it, right? So once you can do, like if you want to create your own database instance, right? So once you can do is you can create to this test database. Right?
I think you have to create it first.
Yeah. Okay, yeah, so you create database, right? So like if you do this and you do this again, right? So you are going to see this new database instance here, right? So and that is the database system, like the instance that you just created. And you can actually connect to that database instance. Okay, so like right now I'm in this database instance now. Okay, and then you can start interact with the system. Okay, so if you do this, you are going to get essentially all the relations in this database instance. So as you can see, there's a new instance. So we have done nothing, right? So there's new like no relation that you can see as a user. And then you can start to create, right? So like we talked about DDL in the last lecture, right? So if you really issue this query to the database, what's going to happen? If you run it, right? So database is going to return, right? So if you just list all the table again, right, you can see, this is actually, I have one new relation now, right? I have a relation with the name professor, right? So it's a table, right? So the owner is your username, right? So, and then you can keep creating relation like this. You can do this, right? So then I have 2 relations, right? And then you can actually start to manipulate the data you have. For example, if you do insert into like this query, right? So it's going to insert 1 new tuple into the relation, right? So as you can see, if you run this, they're going to say, okay, you just insert 1 tuple, right? And then you can actually do selection. You can query your data, right? You can, for example, if you select star from professor, right? You are going to get the result look like this. Okay, if you look at this, this is actually, this is a schema, right? So you have 4 columns in the table, and I have 1 tuple. And this tuple is just the one that I just inserted, okay, into the table. Okay, and then can keep doing the insertion, right? You can do this, you can do this. If you select again, right, you can see, after these 2 insert queries, right? So now I have essentially 3 tuples. Okay, so I mean, after you have this, you can actually do whatever you want to actually kind of play with your data. Okay, so for example, you can write interesting queries. For example, maybe you can join. You can see whether I can join the same table with itself. Yeah, you can actually play with it, right? So give me, I want to join professor with professor for whatever reason. I want to join them on level. Yeah, and you can actually see what you are going to get, right? So here, like you are going to like essentially do a cross product, like between the relation itself, right? So essentially, so and you can actually think about your expectation, right? So if you do this, essentially you are going to say, I'm going to have 5 tuple in the output, which makes sense, right? John is going to be joined with itself. David, Anna, you're going to have essentially like 4 tuples as a cross product, right? So that's what you are going to get, and you can play with it, okay? And then there are different ways that you can actually interact with the database system, okay? And we are going to look at one way that you can actually connect to a database from almost any programming language that you have today, Okay, so let's look at one interaction model if you want to connect that using Python, right? So I first install some dependencies. Okay, so from any programming language, right? So essentially, once you can do, you can always connect to your database engine. Okay, so like different programming language give you different ways of connecting it, but it's always have the same structure. You are connecting to a database server, the thing that we just started. Okay, as a user, this is your username. You have your password, right? So the host, the port, right? So it's actually the host and the port that your database server is actually listening to. Okay, and they want to connect to this database instance. So like again, if you are doing C++, you are doing Java, right? So you have different syntax about how to connect it. The structure is always the same. You have a database server running as a process in the background that listening to this part. Okay, and then you can actually connect that. If you run like psql, like just what we have done, right? You can actually connect it directly, right? Using psql, right, as a client, and then you can actually connect that in programming language. Give me the user, give me the password, give me the host, give me the port, give me the database instance name, and then you are going to connect to the database. Okay, and then what's going to happen is you can actually define what they call a cursor, right? You can think about this. It's like a cursor point to like one tuple in the output. Okay, and then you can actually like run a query like this: cursor execute, run this SQL query, right? And then what you can get is you can actually enumerate every single tuple in this cursor, and you can get the result from your database. Okay, and at this point, this L is actually one variable in your program that you can do whatever you want with it. Okay, so this is one really popular way of interacting with the database. You connect to it, you query it, and then you get your cursor. You can enumerate it, and every single time you move the cursor, you get one object in your program that you can do whatever you want. Okay. Yeah. So and you can interact with database in other ways, right? So for example, here you can interact, like you can run kind of like create a repo, right? So by just connecting to database directly, right? Here you can see, yeah. So if you run some SQL query, you can do this, right? So when you go back, right? So you can go through the tutorial, right? So then you can get a feeling, okay? And then we talk about data loading, right? So you can actually like also get the data out of the database. For example, here in this database instance, right? So I have my professor table, right? So this is the content because I just run this query. So you can like literally copy the result out of the database, right? By just putting them into a CSV file, right? So if you do this, so let's see what's going to happen, right? So this is my I'm in my operating system now, right? You can see there's actually one file, right? So which is this file, right? And you can see, yeah, this you can actually also get data like out of your database, okay? And similarly, you can actually load data into database. For example, let's create some CSV file, right? It looks like this. And then if I connect my database, I can run this query to actually load data, right, from this file into my lecture table. And then if you do the selection over lectures, right, so you can see, this is the 3 tuples, right? So that I just loaded, right? And you can just do a whole bunch of queries. You can do join, right? You can find a professor who teaches databases, right? So on and so forth. So this is just also a quick walkthrough of different ways of interacting with the database system, and also get a feeling that as a user, how we are going to use it, okay? So when you go back home, either you can kind of go through the Katacoda like tutorial by yourself, okay? You can follow that step by step, and then you are going to have a virtual machine essentially in your browser that you can actually play with different type of SQL queries. If you are not comfortable using Katacoda, all the content are on GitHub. Okay, you can follow it step by step. in a Linux system, a Ubuntu system, right? So you should be able to like replicate the same experience, at least a very similar one. Okay. So what I want to get to do today when we go back home is try to go through the installation process. Okay. And then next week, Wednesday and Friday, we are going to have our teaching assistant here, and we are going to write a SQL query together. Okay, so this is one thing that it's very easy to learn on a piece of paper. It's also very easy in practice, but if you never practice, it's very hard for you to connect, these two parts. Okay, cool. So this is we talk about some basic basic functionalities like provided by database and SQL, right? And we talk about essentially one example of how you as a user can interact with the database system. Now let's talk more, okay? So, and this is actually very interesting and it's actually very deep theoretically. And it's caused a lot of interesting behavior in database system. And that is about incomplete information. So if you think about what we have so far, right? So we are assuming that whenever I have a database, I know all the values, right, in a relation, right? What do I mean, right? So I have a database instance, yeah. So that I have 2 lectures, right? So lecture ID, I know that. Title of the lecture, I know. Credit point, professor number, I know all the information, right? But however, in practice, that's not always the case. Because often in practice, we have incomplete information. For example, it is entirely possible that some of the value are not applicable, right? Maybe I don't know how to put it, right? Maybe I have a lecture. This is a bad example, right? So maybe I have a lecture without title, right? I hope that doesn't happen in this database, right? But maybe in some databases, right? For example, you are doing a survey, right? You are asking people questions, right? Some of the questions, right? So it's not applicable, right? So in that case, what should I do? Right? I don't know the answer, right? And sometimes it's simply missing data, right? Again, you are doing a survey, right? So some of the people, they do not fill in all the questions, right? In that case, I don't know the answer, right? So there could be missing information and incomplete information in your data, right? And how can we model that? And that is actually a very fundamental question. So, and also second question is, when you have incomplete information, right? How can we query that, right? How can we write a query over something that I don't know about, right? So that is actually a very interesting topic in database theory, right? So, and we are going to talk a little bit about that. Okay, so there are really a lot of different ways to deal with incomplete information. Here we are going to talk about one of that. Is by using a special state called null. Okay, so the high level idea is whenever I have a relation and whenever there's a value that I do not know, I replace that value with a special state called null. Okay, so there are actually, again, different ways, but this is probably the most popular way you are going to use in a practice database system. So what do we mean by replacing some value with null, right? So let's go to the formal semantic of that. Now again, I mean, if you read the database theory book, right? So that's a whole chapter in the database theory book, and it's very, very deep. But here we are talk about a little bit high level intuition behind it. So essentially, null is a state, it's not a value, and it's going to become clear what do we mean by that. So assuming you have a table look like this, is a null state. Here I have 3 tuples corresponding to 3 person, right? So each of them have person ID, has name, have age. I do not know the age of Kevin, so I put the null there, okay? And then I run a query over it. I want to select all the person with age smaller than 30. What do we mean by the answer, right? What is the semantic? What is the formal semantic of the answer? So the formal semantic here is very interesting. So essentially, if you think about what null is, it simply knows I don't know, right? I don't know the value. What do I mean I don't know? Well, I mean, one thing that I could mean, and there are multiple things you can mean by saying I don't know, right? So, but one thing that database assume when you say I don't know, it means that it can take a value, any value in the domain. Okay, so here your age is an integer. If you put null there, you are essentially saying that I don't know the value, I don't know the age of Kevin. So what the database, how database read about this is that, okay, so you don't know. In principle, right? I'm able to take any value there. Your null state could take any value in that domain, all the possible integers. And logically, what's underneath the cover, right? You really think about theoretically. When you have null your input relation, you are essentially defining a whole bunch of possible parallel databases. Each one of them doesn't have the null state, but just feeding different values to each of those. For example, I could have one possible state. I don't know whether this is a true state or not, but it's definitely possible. Right? With null equals to with the null state filled in by 1. Okay, I could have another state where I have null filled in as 2, as 30, so on and so forth. Right? When you have null, when you say I don't know, what's underneath the cover is I define all the possibilities that this state could take. Okay, so this is really, really beautiful. Yeah, and formally speaking, when you are running a SQL query over this unknown piece of information, what you are trying to do is really try to run this query over each of these possible state. Right. For example, if you run your SQL query over the first state with the null state kind of filled in as 1, right? So your result will have both Kevin and Anna, right? Because your age 1 is smaller than 30, right? If you do that on second state, right? Yeah, so you got going to have Anna and Kevin, right? But when you run on the third state, right? So you are only going to have Anna because now Kevin's age is larger than 30, right? So on and so forth. You are going to have this infinite amount of answers if your domain is infinite. Right? And then what should you return to the user? Right. This is very interesting because there's conflict between all those results, right? So once you can do is you can take what they call the sure answer. That is, no matter which value you take on your unknown state, this tuple will always be in my answer. Okay, so if that tuple exists, you can actually return that as the answer to your query. And if you forget about what's on the right-hand side by just looking at this one, it actually makes sense, right? For example, I have like a 3-person, I don't know the age of Kevin, right? And I want to find out the person who is younger than 30. Yeah, of course, I shouldn't return Kevin because I don't know his age, right? So, and if you follow this semantic, you are going to get something that make a lot of sense, right? So here you are going to say, so I check the age. John is larger than 30. I do not return it. Great. Anna is like this is 29, right? So I'm going to return Anna. I check Kevin, right? It's actually I don't know the age. I don't know whether it's smaller than 30, larger than 30. I don't know, so I do not return it. Right. So to really formalize that is what you have on the right-hand side. Okay. You essentially try to get the sure answer that no matter what value I'm going to take on the null state, I am going to have that tuple in my result. Okay, which means that the database is trying to become really conservative, right? When it's trying to give you the answer. That's a high-level idea. Yeah, go ahead. Further questions. Yeah.
Yeah. So there's one remark in the chat which is interesting, in my opinion. Isn't this the same as just ignoring null? So it's not like maybe not.
Oh yeah, so give me like 1 more minute. So we are going to go to that in the next slide, actually. Yeah.
Okay.
Yeah, perfect. Oh, by the way, thank you so much for reading all the messages. It's really helping a lot. Yeah, thank you.
No problem. No problem.
Okay, great. So cool. Yeah. So now this is a formal semantic, right? So I think you guys asked a very natural question. That is there any kind of simpler way for you to define? Is it like this one, just ignore null, right? So as you will see, yes, like yes and no, right? Because That depends on your query, actually, right? So that also depends on where null is, right? So, but whenever you are not sure, you can always go back this formal way of thinking, okay? So this is logically, formally what we are trying to achieve, right? But of course, there's a whole bunch of smarter ways to achieve that. For example, in some cases, it's going to be equivalent as, okay, just ignore null, okay? But in some cases, it will not be like that, okay? So that's why it's important to have the formal framework first, and then we talk about each of the kind of specific cases, okay? Okay, so in many cases, if null is on the selection condition, what you are going to have, essentially, you have a 3-value logic system, okay? So we can actually define the semantic of operations over null. For example, if you have null plus 1 or null times 5, whatever, it's also give you null, okay? Whatever arithmetic operation you are doing over null is going to be null, okay? There's something I don't know. I increase that by 1. I still don't know about that, right? So of course, you are going to have a question like, what if I just multiply that by 0, right? So I think like at least in practice, right, null times 0 is still null. Okay, whatever you do is still null. Okay, whatever operation you do over null is null. Okay, and then whenever you compare, okay, what you're going to have is if you compare null with null, it's going to give you one value in a 3-value logic system. You don't always have true or false anymore. You have another state called unknown. Okay, simply I don't know. If you compare null with null, whether null equals null, I don't know, right? Because I don't know the first value, I don't know the second value. If I compare them, I still don't know whether they're same or not, right? So I don't know. I simply don't know. And if you compare null with kind of like a value, whether null is smaller than 13, I don't know, right? How can I know, right? So, and then if you say whether null is larger than null, I also don't know, right? So most of the comparison involving null will give you a special state called unknown, okay? And then you can actually define a 3-value logic system. You have true and false and unknown, okay? And you can rewrite all those logical like operation over them, okay? So if you do not, right? So if you do not true, it's going to be false. If you do not false, it's going to be true. If you do not unknown, it's still going to be unknown. And if you do and between them, you are going to get something very actually natural, right? If you do and between unknown and true, it's going to be unknown. If you do the and between unknown and false, it's going to give you false because it doesn't matter what that unknown value will take. You can define all, right? So essentially you can define kind of a 3-value logic system. And then that actually makes it much easier in practice to evaluate that query. Okay, and also make that easier for you to understand that query. So here, right, so let's look at this example. You have the lecture table, right? And then you have a special state null here. And then I want to find all the lecture. And then my conditions is as follows. I want my professor number larger than 2,200. Or I want my professor number smaller or equal than 2,200. If you are talking about a system without null or without this 3-value logic system, right? So this query will actually always evaluate to true in this condition, right? Because like if you like calculate the all here, then it's always true if you do not have unknown, right? However, now we are talking about a 3-value logic system. What do we mean by that? So we are going to like look at how this condition evaluate for your first tuple. We will have null, right? So in this case, both of these two components is going to be evaluated to unknown because you compare null with 2,200. I don't know whether it's larger or not, right? If you compare the second one, I also don't know, right? So essentially you have two unknown and you try to do all between them, the result is going to be unknown, okay? And when you do the selection, I only select tuples where the condition evaluated to true, okay? And in this case, if you run this query over my input, it will not return anything, Okay, so this is actually a simpler way for you to think about this. You do not need to go back to the formal semantic that we talk about, right? But if you want, you can do that. You can unroll this relation into infinite amount of possible relations. Each one of them have a different value here. And then you run this query, right? And then you are going to see the result going to going to look like this. Okay.
So I have a question regarding the arithmetic.
Yeah.
Why is null times 0 null? Because-
Yeah, so that's a that's a very good question. So to be honest, I don't know. So I hope I have a better answer. But actually I don't know. So I think let me double check whether that's really what happened in SQL. But I think in SQL that's what you get.
Okay.
Yeah, it's not. Yeah. So where's my tool? Yes, here, right? So like yeah, so just go back to this, right? So essentially I select null times 0, right? So if you run this query, you are going to get one relation null, right? So yeah, so with one value here. To be honest, I don't know the fundamental reason this like behind this. Yeah, to be honest, I don't know, right? So I'm sure there are some reasoning going behind it, but to be honest, I don't know. Yeah, I can try to look it up. I don't know where I can find. Yeah, let me try to look it up, but I'm not sure I can find the reason. Yeah, but there should be some reason behind it. Okay. Great. Yeah. So essentially, if you look at null, right? So it really introduced many corner cases in SQL that you need to be careful about, right? So this is just like one, essentially one example, right? So and then, right? So if you run select start from lecture, right? So you do not have this problem, right? Because I'm not trying to filter any tuples out, right? So I'm going to get all the tuples. Okay. So one thing that we need to be really clear is null is a state, not a value, right? So essentially you cannot really compare them, right? So if you do whether null equals null, you get unknown, right? Instead of get yes or true. Okay. So what if you want to really say, whether the state, so what if you want to compare between two states, right? So they are all in a state that is unknown, right? So in this case, there's a special keyword for to do that. You can say whether null is null. Okay, we want to compare two state. You do is, right? Whenever you want to compare two values, it's always like the equal thing. Okay, so if you do null is null, it's going to give you true, right? Because here you are comparing two state. Both of the two values are in a state that you have no idea about. Okay, in that sense, they are the same. Okay, so when you want to compare the state, you put yes, like you put is here. We want to compare value, put equal. When you compare null as value, you get unknown because I don't know the value. I don't know whether equal or not. When you compare null as state, you get true. Okay. So let's look at one example. Right. So in this case, right. So
can I ask a question to state and value?
Oh, sure.
Some databases I know treat the empty string as null. Is the empty string a state or a value in that case?
Okay, so that's really a little bit okay. So okay, in practice, everyone implement a different SQL standard, right? So I don't so can you tell me which database it is?
Oracle.
Okay, so and what do you mean it treat empty string as value? You mean when you do data loading, when you have an empty string in your CSV, after you load it, it is null. So is that what you mean? Or if I say I have a column with a type string, I put an empty string, it's treated as null. So like which one do you mean?
I mean the case that you can do is null, and if it actually is an empty string in the column, it evaluates to true.
That's I'm not sure. That I'm not sure. Maybe we can try it. Well, let's do this first, right? This is true. Let's try to write something like this. This is should not be true. At least in PostgreSQL, that's not the case, right? Let's see what happens in Oracle. Oh, slow. Yeah, that I need to try. Yeah, so at least in PostgreSQL, that's not the case. Maybe there's some syntax sugar, that maybe some additional assumption in Oracle. But essentially, every single database implements a slightly different SQL standard. But I think for PostgreSQL, as we see, it's not the case, right?
Okay, thanks.
Yeah. So another caveat is like whenever you are doing data loading, that could be the case, right? So when you put the empty string in the CSV file, the database might interpret that as you don't know the value, you put null there. But I think when the data is already in the database, it looks a little bit weird to me if empty string in a column whose type is string is being treated as null. That will be weird, but maybe there's some kind of vendor specific type of assumptions or functionality or features. Right? So yeah, but in PostgreSQL, I don't think that's the case. Yeah. Okay. Cool. So we'll have a table like this, right? So when you say, okay, I want to select from like a lecture where personnel number equals to null, right? So in this case, of course, you are going to get an empty relation, right? Because if you do the first one, null equals null is false, so it's unknown. I do not return it, right? So on and so forth. So on the other hand, if you do this, I want to select from lecture where personnel number is null, right? So like in this case, right? So you are going to get one relation with one tuple, right? Essentially, you are comparing the state, right? The first tuple has the state null, right? In this case, it's going to be true, right? So the second state, you know the value, whether you want to compare that with the state for which you do not know the value. Of course, they are not the same in the state level, right? So you are not going to return the second one. Okay, now in aggregations. Now it's going to be really complex. Okay, so actually let's do that next lecture because it's getting really complex. Yeah, so we are really doing now in aggregations. So it's very tricky. So let's just finish up for today, and then we are going to do kind of SQL practice next week. So essentially we have 2 lectures in which the teaching assistant will be here to actually make sure we write the SQL query together. And after this, we can talk about more additional functionality we have in database, like null, like view, right, like recursive queries, right? So and also other things. Okay, cool. So I think that's all for today. I will be here to answer whatever question you guys have. Otherwise, I'll see you guys on Wednesday. Thank you. Okay, so if there's no questions, I'll see you guys on Wednesday. Thank you.